Now I create my table. And as I mentioned, please try to get used to this because in the next chapter, I'm going to add 2 more rows here. I look at the domain. I see negative infinity, negative 1. I see 0 has to be in the table. And I see 2. And parenthesis to the left. And the bracket touching to the right. And then infinity. Then I know it's an overkill, but it's safe. So this uses 1 minus the square root of x. The square root of x over 1 minus x. This uses x squared minus 1. And this is with x plus 2. So there is no discussion there. And for each portion of the graph, I have clear x values, right? So here, if I plug in negative 1, I get the square root of 2, right? Did I copy everything correctly? Okay. So this is the square root of 2. Now, if I go to negative 3, then I have the square root of 4, and I get a 2. Is that correct? Yeah. In the middle. When I plug in 1, I have 0. When I plug in 0, I have negative 1. When I plug in 2, I have 3. Is this clear? These ordered pairs must be there. And then when I plug in 2, I get 4. When I plug in 3, I get 5. So far, so good? Okay. So now I graph. And I have negative 3, comma 2, negative 1, comma 1.4. And this is a square root. The graph must look like this. At negative 1 is 0. It has to be open. At 0 is negative 1. And at 2, of course, at 1 will be 0. And at 2 is 3. But this is quadratic. Some of you graphed it as a v function. This must be quadratic. Quadratic means it has a minimum and goes up. So it has to look quadratic. Then 2 comma 4 is this point. And then 3 comma 5. I have the domain established. Can anyone give us the range?
So, negative 1 to 3.
Negative 1 to infinity?
Yeah.
Because it will exist for any x value.
Even though it's separated at...
Because this goes to infinity. And this goes to infinity.
Okay.
So now I can answer the questions. I'm also asked to write the definition of the limit of continuity at a point. So this is limit. We cannot forget this. This has to be committed to memory, like the definition of f prime. Like the square root of x prime. How much is the square root of x prime? Very good. Like 1 over x prime. Negative 1 over x squared. So the same thing here. As x approaches a from the left must equal the limit of the function as x approaches a from the right and must equal f of a. This is the definition of continuity at a point. And we have to commit this to memory. So now, I will say clearly, not continuous at x equals negative 1 and x equals 2. It's very clear. How can it be continuous if it's not even defined at negative 1? How can it be continuous at 2 when the limits left and right are 3 and 4? Right? So no. So this is good enough. However, the problem is also asking us to identify if there is a removable discontinuity. A removable discontinuity is when both sides of the limit, or both limits left and right, go to the same point, are equal and exist, but the function is not defined there. Do we have a situation like that? No. So there is no removable discontinuity. There's no discontinuity that I could get rid of. The problem is also asking us to show whether the function is continuous from the left or from the right. The function cannot be continuous from the left and from the right at -1 because it is not defined. Awesome. Now what about here? Is this function continuous from the left of 2? No. Is it continuous from the right of 2? Yes, and I have to write that. So f of x continuous from the right of 2, since the limit of f of x as x approaches 2 from the right equals, for sure, no, that's not continuity. F of 2. Continuity from the right means that the limit from the right and the function value are the same.
What if we wrote 4?
I'm sorry?
What if we wrote 4? Because that's where it's.
You can, but this is the definition. So you can write that this equals 4.
So we have to write F2.
It's fine if you just write the limit from f of x, which is x plus 2. You can write that too. X plus 2 as x approaches 2 from the right is 4. I'm fine with either one. So we answered all questions here. It's not continuous at those 2 points. It's continuous from the right of 2. I presented the definition of continuity at a point. I presented the domain and range. I presented the order of ordered pairs. Does this function have a removable discontinuity? No. And in order to explain, I could say there is no removable discontinuity because there is no point at which the limit from the left equals the limit from the right, but does not equal the function value at that point. So I can write that because it's asking me to explain. So I'm going to say since there is no point at which limit from f of x as x approaches a from the left equals limit of f of x as x approaches a from the right, but it does not equal f of a. This is the definition of a removable discontinuity. The limit from the left equals the limit from the right, but it does not equal the function value at that point, and we do not have a point like that. This function does not have a point like that. Is this clear? But now remember, just looking at one problem and not going back to review the problems we did in class will not be enough preparation for the test, because you will not remember, or you may not remember. Okay, we're working on number 4. So there are only 12 questions, out of which one is extra credit. So it shouldn't be that long. Okay, so we're working on number 4, correct? Any questions on any problem from before? Please form study groups, and between now and Monday, review everything we've done in class and this. Is that okay, everyone? We're working on 4, right? Raise your hand if you're finished and you want me to look at it. Remember what is right thing to do here with a problem like this. I'm not saying that my method is the best and the only one. Yes, summarize all the information in a table before you start, so you don't forget anything, you don't miss anything, and it's clear. It will take 3 minutes versus 10. So I will also identify and say this is such and such, this is not, this is such and such, this is such and such. Oh, okay, I see. I'm sorry. Okay, sorry about that. Finished? And what about this? What does this represent? And I cannot put the bracket. What does this mean? And I cannot make them touch. Do we need more time on this one? Okay. Yes? But it says limit from either side. Or this, you didn't show them.
Oh, yeah, you're right.
Do we need more time? Okay, let's work on this problem together because we only have 10 more minutes and I'd like to do at least maybe 1 or 2 more problems if possible. Maybe the limits. Okay, ready? So every time I'm given a bunch of or pieces of information about a function, I highly recommend summarize the information. It will be easier for you to know how to graph it. So I know you're gonna call me chart lady or something, but yeah, but this is really, really good. It's good summary, okay? And then I check everything off. So it says limit of f of x as x approaches -3 from the left. So obviously I have to have a -3. The limit from the left is 2. So I'm done with this. And the limit from the right of -3 of f of x is 0. So I'm done with this as well. It appears that there is nothing in here. At least there is no, because they're not infinite, left and right. When x approaches -3 from either side, the limit does not exist. And we don't have any information. We could consider that there is a point in there. I can. As long as I'm using what they gave me and I make up stuff other than that, it's fine. So limit of f of x as approaches infinity, as x approaches 2 from either side is infinity. I have to show this. And this is definitely the case. Here I can make one up, but here I cannot. I chose not to. So this is done. Limit of f of x as x approaches 5 from the right. So 5 from the right is infinity. And done. And 5 from the left is -infinity. So this also appears to be very clearly that x equals 2 is a VA and x equals -5 is a VA. There is no doubt about it. Oh, I'm sorry. Of course. Thank you. So limit as f of x as x approaches -infinity, which is here, is 0, which automatically makes this a horizontal asymptote at -infinity. F of 0 is 0. I'm done with that. And the last one is the limit of f of x as x approaches infinity is also 0. I have to show infinity and I have to show 0. So now I really have no difficulties in, I'm going to draw x equals 2. I'm going to draw x equals 5. And I'm going to draw y equals 0. And now I'm ready to graph the function. So from 0 to 2, fine. So at -3, I have an open point at -3, 2, and I have an open point at -3, 0. So from the horizontal asymptote up to 2. So this piece is done. Then from -3, 0 goes through 0, 0, and it goes to infinity. I can do whatever I want. I chose to do this. And I'm done with the middle. Then from positive infinity goes to negative infinity. So this is whatever I want to present. I can do this if I want to, but there is no point. And then from positive infinity to 0. So I show the vertical asymptotes. Now, I'm allowed to add in whatever I want, but not here, not on the vertical asymptotes. But here, if I want to, I can graph this. I can consider that this is 1, 2, 3, 4, 5. I can put a 5 in here because I want to. I can add on and do whatever I want, but I can't change the vertical asymptotes. And I can't change the horizontal asymptotes.
X equals -3.
Right, as long as the limits left and right are still 2 and 3. 2 and 0. Yes, please.
Because there's the horizontal asymptote of y0, are we still going to abide by that graph? Because
Very good question. So here's what I think you're asking. How come that the function crosses the horizontal asymptote? When we talk about a horizontal asymptote of a function has a horizontal asymptote. I'm talking about -infinity, so far away that I don't even see. And I'm talking about positive infinity, so far away that I don't even see. Who cares what happens in the middle? I can't graph a horizontal asymptote showing you a little piece here and a little piece here. I have to graph a horizontal line.
so it doesn't matter unless it's in them.
The answer is a function can cross a slant asymptote or a horizontal one. The only asymptote that a function will never cross is however, the question is very good. Do I have to do this? No. I can do this, right? And then come back from here and do that if I want to. You can change the graph the way you like. Yes, please.
When we're graphing for like tests and stuff, do we have to have the dash lines for asymptotes, or can we have?
No, as long as you write it, but you cannot make these. The point I'm making here is if I see that these two touch, that's incorrect. Okay, because these two cannot touch. They cannot have the same. They will not go like this. They will go like this. So there is a gap.
I meant like for the asymptotes.
This is the asymptote.
No, on the actual graph, because you have like the dashes.
Oh yeah,
Like, do we have to put dashes to?
the horizontal asymptote and vertical.
Or the verticals, like,
Yes, very good question. Every time we graph a function with asymptotes, the first thing we graph are the asymptotes. Mandatory. Before I graph the function. So first I graph the asymptotes. The first thing I did when I graphed this function, I graphed the two vertical asymptotes and the horizontal asymptote, and then I looked at what I have to graph. So when we graph functions with asymptotes, that's the first thing we do.
but they could just be a solid line that we put.
Very good question. They cannot be a solid line. Here's why. They are not part of the graph. So this line, that's why there are different colors, and one of them, these lines are dashed, and the rest of the graph is solid.
Okay.
Right. So these two are not part of the graph, but they have to be there. The horizontal asymptote is not part of the graph, but it has to be graphed. And since they're not part of the graph, I cannot graph them as solid lines. Okay, so at least let's work a little bit on number 5. So we have 3 minutes left. Are we going to be ready for this test on Monday, please? Thank you.
How big of a note are you?
What about no negotiation? What if we negotiate no negotiation?
Wow.
You have a week to redo all problems we did in class and this handout.
You should negotiate.
Is he a lawyer?
Yes.
Was a C lawyer
Good.
A C one
in the Navy.
We are trying to solve number 5. Please. What are we trying to do? So we are working on 5A, correct?
Yes.
Do we have an answer for 5A? These are two functions that we talked about and two functions that I said, please commit these two functions to memory. So what is this function? Yes, what is it? Very good. What happens to this when x approaches 0 from the right? We have to commit this graph to memory. So when x approaches 0 from the right, 1 over x goes to? Perfect. Perfect. Infinity. So this goes to infinity. And then what is arctangent of infinity? Where does that go? If we have to commit the graph of arctangent to memory. The answer is? Pi over 2 indeed. So there is nothing. We just have to think. So 1 over x, the graph of 1 over x is this. So as x approaches 0 from the right, obviously this goes to infinity. And the graph of arctangent, we looked at it so many times. As x approaches infinity, the function values of arctangent approach, which means that y equals pi over 2 is horizontal asymptote. So